Congratulations on hitting the end of this chapter where we were learning about function-like entities, and we had a chance to see that a function-like entity is really something that behaves like a function in that it is going to have a return value, it is going to have a bunch of parameters that act as input, and in the body of the function we will be doing some processing. So we can set up function-like entities, and these are going to be either function pointers, functors, and lambda functions in our C++ programs. We started out by looking at how we could set up function pointers in our C++ program, and the syntax was what you see here. After that, we saw how we could use them as callback functions. This would give us much more flexibility in making our functions much more dynamic. So for example, this modify function would have the ability to change what it does on the fly by changing the callback that we pass in here. So we could make it encrypt, we could make it decrypt, we could even add other functions that we could use to modify the behavior of our modify function on the fly, and this was really cool. We moved on and looked at how we could simplify function pointers using type aliases. Some people think function pointers are ugly, and this is a chance for you to simplify this if you don't like their syntax in your C++ program. You could use a type alias like this, and then in your code you don't have to use this ugliness anymore. All you have to do is use your type alias like we are doing here, and your code is going to be much more easier to read and understand. We also had a chance to learn about functors, and we saw that these were really classes behind the scenes. And what makes them functors is that we are overloading the function call operator. This would give us the ability to create objects of these classes and call functions on them like we do for regular functions, using a bunch of parentheses and putting in a bunch of parameters. And this was really cool. Another benefit of this is that we could use them as callbacks to other functions. And this would give us a bunch of other benefits that we learned about in the chapter. For example, functors could also store state, a thing that regular function pointers cannot do. And this is a huge advantage in C++ programs out there. We saw that there is a whole gold mine of standard functors we could use in our C++ program. We saw a bunch of examples. Here we have std plus, std minus, std greater. But if you go in your favorite C++ standard library documentation, you're going to find a more exhaustive list of these things, and you're going to have to do your own research and see what makes sense in whatever problem you are trying to solve with C++. We saw that we could set up functors with parameters, and this would allow our functors to store state. And we saw that this was a huge advantage to regular function pointers because this would make our program much more smarter. For example, we could use this functor here to decide if something is in a given range, and good luck trying to do that with regular function pointers. That's going to be really hard to achieve. But functors make this really easy to achieve once you understand how they work behind the scenes. We also had a chance to see that lambda functions are modeled as functors behind the scenes. So if we have a lambda function like this, the compiler is probably going to generate a functor that looks like this behind the scenes, and it is going to support all the logic that we are doing in our lambda function. This is really cool to understand, especially if you want to debug your lambda functions code. We also saw that we could use lambda functions as callbacks, and this is not a surprise because lambda functions are really functors behind the scenes or in the eyes of the compiler. And this is a good example of how you could pass a lambda function directly as a callback to your modify function, and this is going to work really well. Some people find this confusing, especially beginners, but my bet is that as you progress in your career as a C++ developer, you're going to get used to this and you will be using code like this all over the place. Next, we had a chance to look at how the lambda capturing mechanism works behind the scenes. We saw that the compiler would set up a bunch of member variables in our functor and then use those member variables to store copies or references to the data that we have captured in our lambda function. And this is really cool to understand. Next, we saw that it is important to capture the this pointer if you set up a lambda function inside a class object. If you don't do that and try to access the class member variables in a Lambda function, you're going to get a bunch of compiler errors, and you need to be aware of this. We close the chapter by looking at std function, a facility we have in C++ to abstract away different kinds of function-like entities we can use in our C++ programs. We saw that we could use an std function object to store function pointers, functors, or even Lambda functions, and this would make our functions much more flexible to work with, in that our users are not forced to either use function pointers, functors, or Lambda functions. They can use any kind of function-like entity they want in our program, and everything would just fall in place. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this one. In the next one, we will learn about the standard template library, a whole gold mine of container or collection objects we can use to manage data in our C++ programs. Go ahead and finish up here and meet me there.